So this video is on our Chapter 4MA homework number 19, the tangent and the cotangent one from Tuesday, May 25th. So before we get started on this, I added a page on for myself just as a reference. Just to understand the sine and, the tangent and the cotangent. So remember that tangent of an angle is equal to the sine over the cosine. Or the y over the x when I'm on the unit circle. Okay. And so when we're doing this, the one thing you want to pay attention to is whatever makes your cosine 0 or your x being 0, that is where we're going to have an asymptote because we can't have 0 on the bottom. And so that is going to occur here and here at the pi halves and the 3 pi halves and so on. Now, what we don't want to do when we're graphing these, we don't want to start at 0 like we normally do, and then be going, and this is our positive tangents. Okay, this is going to be our positive tangent. All of my trig is positive there. And then have an asymptote in the middle of my graph and then continue with my negative tangents. Okay, so we're not going to go from 0 to pi. What we want to do is we do want to have both positive and negative tangents. So we're going to start down here and we're going to go all the way from one asymptote to the other asymptote. And when we're doing this, what you want to remember is don't think of this as being 3 pi halves. Think of it as negative pi halves. So I'm starting at negative pi halves, going to 0, continuing going to pi halves. So we're going from negative pi halves to pi halves. Okay. Now the values that we're going to be plotting or dealing with, this right here is going to be undefined, which means asymptote. As I'm going around this point here, which is at negative pi force, is going to be -1. Okay, so I'm going to be plotting -1. And here, let me just, so I'm basically going to do undefined -1. And again, this is negative pi force is where that is, but I'm going to be doing undefined. Here, I'm going to, so undefined -1. And then here, this is 1, 0. So this is going to be 0 that I'm going to be plotting. Okay. And then here again, this is going to be a +1, and that is pi force. And then up here at pi halves, again, that is undefined or an asymptote. Okay. So my asymptotes normally are going to be negative pi halves and positive pi halves is kind of what I'm looking at. And your period is normally pi unless it's been adjusted, and then it's going to be pi divided by b. It's basically the distance from this asymptote to this asymptote. Okay. Then if I'm dealing with cotangent, okay, so if I'm dealing with cotangent, so cotangent is going to be cosine over sine, or if I'm on a unit circle, x over y. So wherever my sine is 0 or my y is 0, that's where I'm going to have undefined. So it's 0 here. So this is going to be undefined, which means asymptote. And it's also 0 here. So again, this is going to be undefined or asymptote. So I am going to be going from 0 to pi asymptote to asymptote. So I'm going to have one asymptote at x equals 0 normally, the other asymptote at x equal pi normally. And again, your period is going to be pi divided by b. And so as I'm going around my graph, I'm going to be plotting undefined, 1, which is at pi force, 0, which is at pi halves, -1, which is at 3 pi force, and then again undefined. Okay, so now let's go to the start. Okay, so this is going to be tangent of x over 2. Amplitude is 1, vertical shift none, period. Now for my period, I am going to take pi divided by 1/2, which means that I am going to end up with 2 pi for my period. My phase shift is none. So when I'm trying to find my asymptotes, okay, if I take my b times x minus h, which is that, I take x over 2, and I set it equal to negative pi halves, which is one of my asymptotes normally, and I set it equal to, oops, and I set it equal to positive pi halves, and then I work it out. So to work it out, I am going to multiply by pi. Those are going to cancel out. I mean, not by pi, sorry, by 2. I don't know why I'm saying pi. Probably because I'm going to get as my answer here, x is going to be negative pi. And as my answer here, x is going to be pi. So I'm going to have my start at negative pi. And then my ending one is going to be at pi. Okay. So when I'm graphing this, I'm going to go from negative pi to pi. Those are the same distance on either side. I always graph 5 things. My asymptote and asymptote are going to be the start and the back. And then in the middle, I'm going to have a -1, 0, and a 1. So let me put my marks in here. Okay, I have my asymptotes at negative pi, and I have another one at pi. And remember, when we're dealing with our tangent, okay, I'm just going to draw over here real quick. When I'm dealing with my tangent, I am going from here to here. So I'm going to do negative and then positive. So when I'm doing this, I am going to be, I always start with my 0, because my 0 would be this one right here at 0. And then I'm going to be graphing my -1 here and my +1 here. So first I'm going to have my -1. So let me just actually put -1 here, +1 here. And so I'm going to be starting down at -1. Then I'm going to be at +1, and then there is my tangent. Okay, on number 2. So my amplitude is 1. It's a negative, so it's going to flip. So I do need to pay attention to that. My vertical shift is none. My period is going to be pi divided by pi force. So when I do that math, let me move this so I can zoom in a little bit more. So when I do that math, I'm going to have pi times the reciprocal. And so those are going to cancel out. So my period is 4. Phase shift none. Okay. And then my asymptotes are going to start. So here, let me do this in do it in purple. So I'm going to take this pi x over 4 and set it equal to negative pi halves. Let me work that out. I'm going to times by the reciprocal, which is 4 over pi, 4 over pi. And I'm going to get x equal because those are going to cancel. And over here, that goes into this twice, and then those are going to cancel. So I get a negative 2. And if you want, you know your period is 4. So if one asymptote's at negative 2, then the other asymptote has to be 4 away, which is going to be positive 2. So I'm going to have negative 2 and positive 2. If that doesn't make sense to you, you can again take the this pi x over 4 and set it equal to, instead of a negative pi halves, a positive pi halves. But if you know where you're starting and you know your period, it's going to be that far away. So it's up to you how you want to do that. Okay, so let's see. So for this, not having any shift, it is going to flip. I'm going to be going from negative 2 to positive 2. Okay, and so I have an asymptote at negative 2, x equal negative 2. I have one at x equal positive 2. I am going to be having 1 and negative 1. And what's going to change with this one, because of that negative in front, instead of starting below like I normally would, I'm going to be starting at positive 1. It's going to flip. So it's going to kind of look like it's going to look like a cotangent in terms of where it's at starting above and ending below. Okay. On number 3, so on 3, my amplitude's 1, my vertical shift is none, my period is going to be just pi because there's no number in front of my x, and my phase shift is going to be a negative pi force. So I am going to be taking this, and I'm going to be taking that and setting it equal to negative pi halves. And I can also set it equal to positive pi halves. So when I work this out, negative pi over 2, I'm going to rewrite as negative 2 pi force. And I'm going to minus pi force. And so I am going to get a negative 3 pi force. Now, I know my period is pi, so I can actually add pi onto negative 3 pi force, which is really 4 pi force. And that means I'm going to end at, so at 4 pi force, so at pi force. But again, I can also finish the math for the second equation here that I haven't done yet. So if I do that math and I subtract pi force, I'm going to have basically 2 pi force minus pi force, which is pi force. So you see, I get that same answer in both cases. So I'm going to be starting at negative 3 pi force, and my ending asymptote is going to be at pi force. Okay. So when I space this, I have to be careful because I'm going from negative to positive. So let's say that this is my negative 3 pi force, 2 pi force, pi force, this is 0, and then this is pi force. So again, this is going to be negative 3 pi force, 2 pi force, pi force. I'll just kind of label every other negative pi force, sorry, and then this is pi force. My asymptote, I have one here at x equal negative 3 pi force and at positive pi force. This is a positive tangent, so that means I'm going to have my 0 here like I normally would. I'm going to, I forgot to put my y value, sorry. Negative 1 and positive 1. So I am going to, for our tangent, we normally start with the -1, then plot our 0, then plot our 1, unless it is a negative and it flips. So let's take a look at number 4. So a little bit more going on with number 4, just in terms of more our period and our phase shift than anything else. The negative is going to flip it. So my amplitude is 1, none for my vertical shift. Now my period, I'm going to take this pi force. So it's going to be pi over pi force, which ends up being pi times 4 over pi. So we end up getting 4. So on this, with my phase shift, I'm going to basically set this to 0 and work that out. So if I'm doing that, let me just, I'm going to do the math here. So pi x over 4, I'm going to basically set that whole thing equal to 0, which means the pi halves is going to come to the other side. I'm going to times by 4 over pi. And I am going to get x is equal to 2. So I'm going to start at 2. Now, in terms of my asymptotes, again, I'm going to take this pi x over 4 minus pi halves and set it equal to a negative pi halves. And I can do the same and set it equal to a positive pi halves, or I can just use my period. Let's see what type of number I get. So I am going to add pi halves to both sides. So when I do that, I'm going to get 0. And so my first asymptote is going to be 0. So that's pretty easy to add 4 onto. So I'm going to have one at 0, and then I'm going to have one 4 away, which is at 4. So 0 and 4. Okay. So I'm going to be 0, and then that's 1, 2, 3, 4, 5. And so that's 4. This is 0. I'm going to be going 1 above and 1 below. Okay. And so my asymptotes, I have 1 here at x equals 0. I have 1 at x equals 4. And then, since I don't have any vertical shift or anything, I'm going to have my 0. Now, because of that negative in front, normally I would start down, but it's going to be a flip. So I'm going to start at my 1, then 0, then -1. And so it's going to look like a cotangent. Okay, on number 5. So on 5, this one is going to have an amplitude and a vertical shift. And on this, number 5 is the same, same problem. So here, we're just going to skip this one here. Okay, that one's going to be skipped. Okay, so we'll do this one here. Oops, I'm scribbling all over everything. Okay, so on this one, my amplitude is 3. Just kind of watch the order. This +2, that usually we see over here like as a +2 like that. Okay, so it is kind of the same thing. It is the same thing. So my vertical shift is 2. My period is pi over b, but my b is just 1. So this is going to be pi. My phase shift, none. So so basically what's going to happen here is my, everything, I'm not shifting it anywhere. My period is not going to be any different. So I'm actually going to have them where I normally would, which is negative pi halves and pi halves. That's where it's going to be. So if I'm doing this graph, I'm going to have negative pi halves and pi halves. Okay. Now I'm going to have a vertical shift of 2. So let's say this is 2. Here, I'm going to space this down a little bit more. Let's say this is 2. My amplitude is 3, so I'm going to go 3 above that, which means I'm going to be up at 5. And I'm going to go 3 below 2, which means I'm going to be down at -1. So I have an amplitude at negative pi halves. I have an amplitude at pi halves. Now, with this vertical shift here, okay, with this vertical shift being at 2, okay, I'm at a height of 2. It's a positive 3, so I'm going to start below like I normally would. It's just now I'm starting 3 below 2, which is at -1, and I'm going 3 above 2, which is at 5. And then there's my graph. Okay, so again, this number 5, duplicate, can skip. Okay, so looking at number 6. So this is a cotangent. So just a little reminder for your cotangent, okay? Cotangent has asymptotes where your sine is 0, where your y is 0. So it's asymptotes here. So this is going to be undefined. Then I'm going to plot 1. Then I'm going to plot 0. Then I'm going to plot -1. Then I'm going to have an asymptote again. That's how my cotangent should look. So my amplitude is 1. It's negative though, so it's going to flip, and it's going to be, instead of starting at a height of 1 and then going down, it's going to go opposite. Okay. Vertical shift none, period. So it's going to be pi divided by 1/2, which is going to be 2 pi. Phase shift none. And then we got to figure out where it's going to end. So if I take this x over 2 and I take that x over 2 and set it equal to 0, which is where my should normally start, I am going to end up getting x equals 0. If I take this x over 2 and set it equal to where it should normally end, which is pi, and I solve, I get 2 pi. Now, you'll notice that if I know the start and I know my period is 2 pi, I can just add that onto it. Okay, but I want you to show you that I would go through the same process I did for tangent, but instead of setting it equal to negative pi halves and pi halves, I go to 0 and pi, because that's where my asymptotes are. Okay. So for this one, I'm going from 0 to 2 pi. So 1, 2, 3, 4, 5. And that's my 2 pi. And I'm going to go up to 1. I don't need to put it that high up. Up to 1 and -1. And I have an asymptote here at x equals 0. I have an asymptote here at x equals 2 pi. And then my graph, that is going to be 0. And then normally my cotangent would start here and go here. But because of that negative, it's going to flip-flop. So it's going to be like a tangent. And so this is my graph. Okay, on 7, another cotangent. So my amplitude is 1, vertical shift none, period is going to be 2, not 2 pi, wrong graph, pi. Pi divided by pi force. So that's going to be pi times the reciprocal. So I end up with 4. My period is 4. My phase shift is none. So since I know that normally I start at 0 for my asymptote, and I'm going to go 4 away from that. I'm going to end at 4. So I'm going to start at 0. 1, 2, 3, 4, 5. And I'm going to end at 4. And I'm going to go up to 1 and down to -1. And so I have an asymptote here at x equals 0. I have an asymptote here at x equals 4. This is a positive cosine. Cotangent. So I've got 0 here, and then my cotangent, I start quadrant 1 is positive, quadrant 2 is negative. So that's my graph. On number 8, my cotangent is, has an amplitude of 1. My vertical shift is none. My period is pi divided by my b, which is 2, so pi halves. My phase shift, if I take this and I set it equal to 0, and I get 2x is equal to pi halves, and I divide by 2, I get x is equal to pi fourths. So I'm going to start at pi fourths. Okay. So if I take this and I set it equal to 0, that is going to be the start of my graph. Well, I've already actually done that. So my start of my graph is going to be at pi fourths. Now I can either take this and set it equal to where it should end at pi and add pi halves to both sides. So 2 pi halves plus pi halves is 3 pi halves. Divide by 2, so that's going to be 3 pi fourths. Or take your period and add your period onto pi fourths. So pi halves is really 2 pi fourths plus pi fourths is 3 pi fourths. So I got it either way. So the nice thing about your cotangents is wherever your phase shift is, that would be where your 0 would be. And that is always your first asymptote. So unlike my tangent where I would set them equal to negative pi halves and pi halves, when I find my phase shift, that is going to be the same as me setting that equal to 0 to find my vertical, my vertical asymptote. And so this is going to end up being the same as this for my cotangents. Okay, so let's see. So I'm going pi fourths to 3 pi fourths. So pi fourths. That's 1, 2, 3, 4, 5. And this is going to be 3 pi fourths. I do not have anything as an amplitude, so this is going to be a 1 and a -1. And I'm going to have an asymptote here at x equal pi fourths and here at 3 pi fourths. And since I'm not having any shift at all in terms of a vertical shift, this is my 0. There's no sign in front that's changing this. So I'm going to start at 1, then 0, then -1. And there is your cotangent. On number 9, so this one again, this 3 you can think of as your vertical shift, like we did in this one. Freezing here. Let me get it so that I have my mouse. So like we did on this one here, same type of idea. Okay. Okay. So on this one, my amplitude is going to be 2 for this. My vertical shift is going to be 3. My period is going to be just regular pi. I have no phase shift, so that means I'm going to be starting at 0 for my asymptote. I'm going to go pi away, so that means my other one is going to be at pi. And what I need to be careful of is when I'm doing this, I need to remember that I do have a vertical shift. Okay, so I'm going to go from 0 to pi. I'm just going to move this for a second. So 0, 1, 2, 3, 4, 5 pi. And I am going to be starting at a height of 3 and going 2 above that. Okay, so I'm going to start at a height of 3. I'm going to go 2 above that, which is 5, and 2 below that, which is 1. We have an asymptote at x equals 0. We have an asymptote at x equal pi. This is a positive cotangent, but my 0 is really at a height of 3 because that is where my vertical shift is. So this vertical shift here, that is going to make my 0 be here. And then my amplitude of 2, and my amplitude of 2 means I'm going to start 2 above and then I'm going to be 2 below. And there is my cotangent. So hopefully this helps you guys out.